The population. Chi-square test 23310 Chi-square test. The chi-square test is an important test amongst the several tests of significance developed by statisticians. Chi-square, symbolically written as chi2 pronounced as chi-square, is a statistical measure used in the context of sampling analysis for comparing a variance to a theoretical variance. As a non-parametric test, it can be used to determine if categorical data shows dependency or the two classifications are independent. It can also be used to make comparisons between theoretical populations and actual data when categories are used. Thus, the chi-square test is applicable in large number of problems. The test is, in fact, a technique through the use of which it is possible for all researchers to test the goodness of fit, test the significance of association between two attributes, and test the homogeneity or the significance of population variance. Chi-square is a test for comparing variance. The chi-square value is often used to judge the significance of population variance, i.e., we can use the test to judge if a random sample has been drawn from a normal population with mean micro and with a specified variance sigma p2. The test is based on chi2 distribution. Such a distribution we encounter when we deal with collections of values that involve adding up squares. Variances of samples require us to add a collection of squared quantities and, thus, have distributions that are related to chi2 distribution. If we take each one of a collection of sample variances, divided them by the known population variance and multiply these quotients by n1, where n means the number of items in sigma to the sample, we shall obtain a chi2 distribution. Thus, S2n S2p1 minus equals sigma bgt. F would have the same 2p distribution as chi2 distribution with n1 degrees of freedom. See Chapter 12 Testing of Hypotheses 2 for more details. 1 Neil R. Ullman, Elementary Statistics, An Applied Approach, p. 234. 234 Research Methodology. The chi2 distribution is not symmetrical and all the values are positive. For making use of this distribution, one is required to know the degrees of freedom, since for different degrees of freedom we have different curves. The smaller the number of degrees of freedom, the more skewed is the distribution, which is illustrated in Fig. 10.1. C2, distribution for different degrees of freedom. df equals 1, df equals 3, df equals 5, df equals 100, 5, 10, 1520. C2, values. Fig. 10.12530 table given in the appendix gives selected critical values of chi2 for the different degrees of freedom. Chi2 values are the quantities indicated on the x-axis of the above diagram and in the table or areas below that value. In brief, when we have to use chi-square as a test of population variance, we have to work out the value of chi2 to test the null hypothesis, viz. H2 chi2 sigma S220, sigma equals as under. SP equals minus 2 NBG1P, where sigma S2 equals variance of the sample, sigma P2 equals variance of the population. N1 equals degrees of freedom, N being the number of items in the sample. Then by comparing the calculated value with the table value of chi2 for N1 degrees of freedom at a given level of significance, we may either accept or reject the null hypothesis. If the calculated value of chi2 is less than the table value, the null hypothesis is accepted, but if the calculated value is equal or greater than the table value, the hypothesis is rejected. All this can be made clear by an example. Illustration 1. Weight of 10 students is as follows. Chi-square test 235s. No. 1 2 3 4 5 6 7 8 9 108 kg. 384045 5347 4355 4852 49. Can we say that the variance of the distribution of weight of all students from which the above sample of 10 students was drawn is equal to 20 kgs? Test this at 5% and 1% level of significance. Solution. First of all, we should work out the variance of the sample data or sigma S2, and the same has been worked out as under. Table 10.1s. No. Sheet weight in kgs. X2 138981240749345204453 plus 636547+0006434167555 plus 8 64848 plus 101952 plus 5251049 plus 204 n equals 10 n area summation equals she 470 n area summation minus equals xxidi 2280 xxni equals n area summation equals 4701047 kgs. Therefore sigma sxxn equals n area summation minus equals di2 1280101311, or sigma s23111 equals Let the null hypothesis be HPSO22, sigma sigma equals. In order to test this hypothesis, we work out the chi2 value as under, chi sigma sigma 2221 equals minus SPNBG. 236 Research methodology equals minus 3111-20101, BG equals 13.999. Degrees of freedom in the given case is N1 equals 10 to 1 equals 9. At 5% level of significance, the table value of chi2 equals 16.92, and at 1% level of significance, it is 21.67 for 9D, F, and both these values are greater than the calculated value of chi2, which is 13.999. Hence we accept the null hypothesis and conclude that the variance of the given distribution can be taken as 20 kgs at 5% is also at 1% level of significance. In other words, the sample can be said to have been taken from a population with variance 20 kgs. Illustration 2. A sample of 10 is drawn randomly from a certain population. The sum of the squared deviations from the mean of the given sample is 50. Test the hypothesis that the variance of the population is 5 at 5% level of significance. Solution. Given information is n equals 10 n Airy summation minus equals xxidi 250, therefore sigma sxxn 2 9 equals n Airy summation minus equals di. Take the null hypothesis as HPSO22, sigma sigma equals. In order to test this hypothesis, we work out the chi2 value as under, chi sigma sigma 222509151015091591110 equals times equals SPNBG degrees of freedom equals 10 to 1 equals 9. The table value of chi2 at 5% level for 9D, F, is 16.92. The calculated value of chi2 is less than this table value, so we accept the null hypothesis and conclude that the variance of the population is 5 as given in the question. Chi-square is a non-parametric test. Chi-square is an important non-parametric test, and as such no rigid assumptions are necessary in respect of the type of population. We require only the degrees of freedom, implicitly of course the size of the sample, for using this test. As a non-parametric test, chi-square can be used I as a test of goodness of fit and E as a test of independence. Chi-square test 237 is a test of goodness of fit. Chi2 test enables us to see how well does the assumed theoretical distribution, such as binomial distribution, Poisson distribution or normal distribution, fit to the observed data. When some theoretical distribution is fitted to the given data, we are always interested in knowing as to how well this distribution fits with the observed data. The chi-square test can give answer to this. If the calculated value of chi2 is less than the table value at a certain level of significance, the fit is considered to be a good one, which means that the divergence between the observed and expected frequencies is attributable to fluctuations of sampling. But if the calculated value of chi2 is greater than its table value, the fit is not considered to be a good one. As a test of independence, chi2 test enables us to explain whether or not two attributes are associated. For instance, we may be interested in knowing whether a new medicine is effective in controlling fever or not. Chi2 test will help us in deciding this issue. In such a situation, we proceed with the null hypothesis that the two attributes viz. New medicine and control of fever are independent, which means that new medicine is not effective in controlling fever. On this basis we first calculate the expected frequencies and then work out the value of chi2. If the calculated value of chi2 is less than the table value at a certain level of significance for given degrees of freedom, we conclude that null hypothesis stands, which means that the two attributes are independent or not associated, i.e., the new medicine is not effective in controlling the fever. But if the calculated value of chi2 is greater than its table value, our inference then would be that null hypothesis does not hold good, which means the two attributes are associated and the association is not because of some chance factor but it exists in reality, i.e., the new medicine is effective in controlling the fever and as such may be prescribed. It may, however, be stated here that chi2 is not a measure of the degree of relationship or the form of relationship between two attributes, but is simply a technique of judging the significance of such association or relationship between two attributes. In order that we may apply the chi-square test either as a test of goodness of fit or as a test to judge the significance of association between attributes, it is necessary that the observed as well as theoretical or expected frequencies must be grouped in the same way and the theoretical distribution must be adjusted to give the same total frequency as we find in case of observed distribution. Chi2 is then calculated as follows: 2 chi2 where equals minus IJDI IJOE IJOA equals observed frequency of the cell in ith row and jth column. I equals expected frequency of the cell in ith row and jth column. If two distributions observed and theoretical are exactly alike, chi2 equals 0, but generally due to sampling errors, chi2 is not equal to 0, and as such we must know the sampling distribution of chi2 so that we may find the probability of an observed chi2 being given by a random sample from the hypothetical universe. Instead of working out the probabilities, we can use ready table which gives probabilities for given values of chi2. Whether or not a calculated value of chi2 is significant can be 238 research methodology ascertained by looking at the tabulated values of chi2 for given degrees of freedom at a certain level of significance. If the calculated value of chi2 is equal to or exceeds the table value, the difference between the observed and expected frequencies is taken as significant, but if the table value is more than the calculated value of chi2, then the difference is considered as insignificant, i.e., considered to have arisen as a result of chance and as such can be ignored. As already stated, degrees of freedom play an important part in using the chi-square distribution and the test based on it. One must correctly determine the degrees of freedom. If there are 10 frequency classes and there is one independent constraint, then there are 10 to 1 equals 9 degrees of freedom. Thus, if n is the number of groups and one constraint is placed by making the totals of observed and expected frequencies equal, the d, f, would be equal to n1. In the case of a contingency table, i.e., a table with 2 columns and 2 rows, or a table with 2 columns and more than 2 rows, or a table with 2 rows but more than 2 columns, or a table with more than 2 rows and more than 2 columns, the d, f, is worked out as follows: d, f, equals C1 R1, where C means the number of columns and R means the number of rows. Conditions for the application of chi2 test: the following conditions should be satisfied before chi2 test can be applied. I. Observations recorded and used are collected on a random basis. E. All the IDMEs in the sample must be independent. E. No group should contain very few items, say less than 10. In case where the frequencies are less than 10, regrouping is done by combining the frequencies of adjoining groups so that the new frequencies become greater than 10. Some statisticians take this number as 5, but 10 is regarded as better by most of the statisticians. IV. The overall number of items must also be reasonably large. It should normally be at least 50, howsoever small the number of groups may be. V. The constraints must be linear. Constraints which involve linear equations in the cell frequencies of a contingency table, i.e., equations containing no squares or higher powers of the frequencies, are known or know as linear constraints. Steps involved in applying chi-square test: the various steps involved are as follows. For d, f, greater than 30, the distribution of distribution is d, f, minus 2, 1. 2 chi approximates the normal distribution wherein the mean of 2 chi and the standard deviation equals 1. Accordingly, when d, f, exceeds 30, the quantity ln 2 chi minus d, f, 0221 qp may be used as a normal variate with unit variance, i.e., z alpha chi 2d, f, equals minus 221. Chi-square test 239. I. First of all, calculate the expected frequencies on the basis of given hypothesis or on the basis of null hypothesis. Usually in case of a 2 times 2 or any contingency table, the expected frequency for any given cell is worked out as under: L expected frequency of any cell equals MNMM, row total for the row of that cell times column total for the column of that cell, grand total OPQPPE. Obtain the difference between observed and expected frequencies and find out the squares of such differences, i.e., calculate OA I2. E. Divide the quantity OA I2 obtained as stated above by the corresponding expected frequency to get OA I2 I, and this should be done for all the cell frequencies or the group frequencies. IV. Find the summation of OA I2 I values, or what we call required chi2 value. DI2IJN ARI summation minus OEIJEIJ. This is the chi2 value obtained as such should be compared with relevant table value of chi2 and then inference be drawn as stated above. We now give few examples to illustrate the use of chi2 test. Illustration 3. A die is thrown 132 times with following results. Number turned up: frequency 1 2 3 4 5 6 1 6 2 0 2 5 1 4 2 9 2 8. Is the die unbiased? Solution: let us take the hypothesis that the die is unbiased. If that is so, the probability of obtaining any one of the 6 numbers is 1/6, and as such the expected frequency of any one number coming upward is 132 times 1/6 equals 22. Now we can write the observed frequencies along with expected frequencies and work out the value of chi2 as follows: Table 10.2 No turned up 1 2 3 4 5 observed frequency OI 16202514 expected frequency EI 2222 OI A -6 OI A2 OI A2 A362222229 62822223876496449363622 and 420 seconds 922 and 6420 seconds 4922 and 3620 seconds. 240 Research methodology therefore n airy summation, OI, A2A equals 9. Hence, the calculated value of chi2 equals 9. Q degrees of freedom in the given problem is n1 equals 6 to 1 equals 5. The table value of chi2 for 5 degrees of freedom at 5% level of significance is 11.071. Comparing calculated and table values of chi2, we find that calculated value is less than the table value and as such could have arisen due to fluctuations of sampling. The result, thus, supports the hypothesis and it can be concluded that the dye is unbiased. Illustration 4 Find the value of chi2 for the following information. Class observed frequency ABCDE8 theoretical, or expected frequency 729244438152447 solution. Since some of the frequencies less than 10, we shall first regroup the given data as follows and then we'll work out the value of chi2. Table 10.3 Class A and B, C, D and E observed frequency OI 8 plus 29 equals 3744 expected frequency A 7 plus 24 equals 31 OI. A OI A2 A6 38 15 plus 4 equals 19 therefore 24 plus 7 equals 31 II chi2 equals minus OEE 6. Minus 12 2BG equals 6.76 AB. I illustration 5 and 36 31st 36 38 and 144 31st genetic theory states that children having one parent of blood type A and the other of blood type B will always be of one of three types, A, AB, B and that the proportion of three types will on an average be as 1, 2, 1. A report states that out of 300 children having one a parent and B parent, 30% were found to be types A, 45% type AB and remainder type B. Test the hypothesis by chi2 test. Solution. The observed frequencies of type A, AB and B is given in the question are 90, 135 and 75 respectively. Table number 3 showing some critical values of chi2 for specified degrees of freedom has been given in appendix at the end of the book. Chi-square test 241 The expected frequencies of type A, AB and B, as per the genetic theory, should have been 75, 150 and 75 respectively. We now calculate the value of chi2 as follows. Table 10.4 Type AB observed frequency OI 90,135 expected frequency EI, OI, AOI, A2 OI, A2 A75 and 15,225,225 75ths equals 3,150 B therefore 75 chi2 equals minus OEE minus 1502 II 225 0 BG equals 3 plus 1.5 plus 0 equals 4.5 Q 225 150ths equals 1. 5 and 0 75ths equals 0 ID. F equals N1 equals 3 to 1 equals 2. Table value of chi2 for 2D. F, at 5% level of significance is 5.991. The calculated value of chi2 is 4.5 which is less than the table value and hence can be ascribed to have taken place because of chance. This supports the theoretical hypothesis of the genetic theory that on an average type A, AB and B stand in the proportion of 1, 2, 1. Illustration 6 The table given below shows the data obtained during outbreak of smallpox. Attacked vaccinated not vaccinated 31,185 not attacked 469 total 500, 1315 total 216 1784 1500 2000. Test the effectiveness of vaccination in preventing the attack from smallpox. Test your result with the help of chi2 at 5% level of significance. Solution. Let us take the hypothesis that vaccination is not effective in preventing the attack from smallpox i.e., vaccination and attack are independent. On the basis of this hypothesis, the expected frequency corresponding to the number of persons vaccinated and attacked would be expectation of AB equals ABN times when A represents vaccination and B represents attack. 242 Research methodology therefore A equals 500 B equals 216 N equals 2000 expectation of equals AB 500 216 2005 4 times equals now using the expectation of AB we can write the table of expected values as follows. Attacked, B not attacked, B total vaccinated, AB equals 54, AB equals 446,500 not vaccinated. AB equals 162, AB equals 1338 1500 total 216 1784 2000 table 10.5. Calculation of chi-square group observed expected OA. OA, I2 OA. I2 frequency OA IAB 3154 minus 23,529 and 529 54ths equals 9.796 AB 469,446 plus 23,529 and 529 44ths equals 1.186 AB 158 162 plus 23,529 and 529 160 seconds equals 3.265 AB 1315 1338 minus 23,529 and 529 1338 equals 0.395 chi22 equals minus OEIJIJIJDI equals 14.642 Q degrees of freedom in this case equals R1 C1 equals 2 to 1 2 to 1 equals 1. The table value of chi2 for 1 degree of freedom at 5% level of significance is 3.841. The calculated value of chi2 is much higher than this table value and hence the result of the experiment does not support the hypothesis. We can, thus, conclude that vaccination is effective in preventing the attack from smallpox. Illustration 7. Research workers classified some people in income groups on the basis of sampling studies. Their results are as follows. Investigators' income groups total poor middle rich A160, 30, 10, 200 B140, 120, 40, 300 total 300, 150, 50, 500. Chi-square test 243 show that the sampling technique of at least one research worker is defective. Solution. Let us take the hypothesis that the sampling techniques adopted by research workers are similar, i.e., there is no difference between the techniques adopted by research workers. This being so, the expectation of an investigator classifying the people in I poor income group equals 200,000 300 times 500 E equals middle income group equals 200,000 150 times 500 E rich income group equals 250 times equals 120 equals 20, 60, 500. Similarly, the expectation of B investigator classifying the people in I poor income group equals 300,000 300 times 500 E equals middle income group equals 300,000 150 times 500 E rich income group equals 350 times equals 180 equals 30, 509. We can now calculate value of chi2 as follows. Table 10.6 Groups Investigator A classifies people as poor classifies people as middle class people classifies people as rich Investigator B classifies people as poor classifies people as middle class people Observed frequency OA 160, 30, 10 Expected frequency OA II 120 OA I2 I40, 60 20 140 120 classifies people as rich 40 180 90 30 30 10 40 30 10 1600 120 equals 13. 33 and 960 equals 15.00 120 equals 5.00 1600 180 equals 8. 88 and 990 equals 10.00 130 equals 3.33. 244 Research methodology 2ij hence, chi2 equals minus IJOEEDI equals 55.54 IJQ degrees of freedom equals C1 R1 equals 3 to 1 2 to 1 equals 2. The table value of chi2 for 2 degrees of freedom at 5% level of significance is 5.991. The calculated value of chi2 is much higher than this table value, which means that the calculated value cannot be said to have arisen just because of chance. It is significant. Hence, the hypothesis does not hold good. This means that the sampling techniques adopted by two investigators differ and are not similar. Naturally, then the technique of one must be superior than that of the other. Illustration 8 coins were tossed 256 times and the following results were obtained. Numbers of heads frequency 0, 1, 2, 3, 4, 5, 6, 7, 8, 2, 6 are the coins biased. Use chi2 test. 3052 67 56 32 101. Solution. Let us take the hypothesis that the coins are not biased. If that is so, the probability of any one coin falling with head upward is 1/2 and with tail upward is 1/2 and it remains the same whatever be the number of throws. In such a case the expected values of getting 0, 1, 2 heads in a single throw in 256 throws of 8 coins will be worked out as follows. Table 10.7 Events are no of heads 01 expected frequencies CFGIKJFHGIKJ times equals 088H120122561 FGIKJFHGIKJ times equals 178CH1211225682628 CHFGIKJFHGIKJ times equals 212122562 hollow circle 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 con TD. The probabilities of random variable i.e., various possible events have been worked out on the binomial principle viz. Through the expansion of p plus q n where p equals 1/2 and q equals 1/2 and n equals 8 in the given case. The expansion of the term NCRPRQNR has given the required probabilities which have been multiplied by 256 to obtain the expected frequencies. Chi-square test 245 events are expected frequencies no of heads 3833512122565 CFHGIKJFHGIKJ times equals 4844412122567 CFHGIKJFHGIKJ times equals 5855312122565 CFHGIKJFHGIKJ times equals 6866212122562 CFHGIKJFHGIKJ times equals 7877112122568 CFHGIKJFHGIKJ times equals 8888012122561 CFHGIKJFHGIKJ times equals. The value of chi2 can be worked out as follows. Table 10.8 No of heads observed expected OI, A2 frequency OI A021111 equals 1.00168 minus 2 and 4/8 equals 0. 50230282428 equals 0.1435256 minus 4 and 1656 equals 0. 29467703970 equals 0. 13556560056 equals 0. 00632284162 equals 0. 577108248 equals 0.5081100, 1 equals 0.00 therefore chi22 equals minus OEIIIBG equals 3.13. 246 Research methodology therefore degrees of freedom equals N1 equals 9 to 1 equals 8 The table value of chi2 for 8 degrees of freedom at 5% level of significance is 15.507. The calculated value of chi2 is much less than this table and hence it is insignificant and can be ascribed due to fluctuations of sampling. The result, thus, supports the hypothesis and we may say that the coins are not biased. Alternative formula There is an alternative method of calculating the value of chi2 in the case of a 2 times 2 table. If we write the cell frequencies and marginal totals in case of a 2 times 2 table thus, ABCD plus AB plus CD plus ACBD and then the formula for calculating the value of chi2 will be stated as follows. 2 chi2 equals BG add BC and ACBD ABCD minus dot operator plus BG 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 BG. Where N means the total frequency, add means the larger cross product, BC means the smaller cross product and A plus C, B plus D, A plus B, and C plus D are the marginal totals. The alternative formula is rarely used in finding out the value of chi-square as it is not applicable uniformly in all cases but can be used only in a 2 times 2 contingency table. Yates, correction. F. Yates has suggested a correction for continuity in chi2 value calculated in connection with a 2 times 2 table, particularly when cell frequencies are small, since no cell frequency should be less than 5 in any case, through 10 is better as stated earlier and chi2 is just on the significance level. The correction suggested by Yates is popularly known as Yates' correction. It involves the reduction of the deviation of observed from expected frequencies which of course reduces the value of chi2. The rule for correction is to adjust the observed frequency in each cell of a 2 times 2 table in such a way as to reduce the deviation of the observed from the expected frequency for that cell by 0.5, but this adjustment is made in all the cells without disturbing the marginal totals. The formula for finding the value of chi2 after applying Yates' correction can be stated thus. Chi-square test 247 2 chi2 corrected equals 05 ch. N add BC N ABCD ACBD dot operator minus plus BG 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 in case we use the usual formula for calculating the value of chi-square viz. 2 chi2 equals minus IJOEEDI, ij then Yates, correction can be applied as under. Chi2 corrected equals 1 1 2 0 5 OEE 0 5 2 minus minus plus minus minus plus 2 2. 1 OEE 2. It may again be emphasized that Yates, correction is made only in case of 2 times 2 table and that 2 when cell frequencies are small. Illustration 9. The following information is obtained concerning an investigation of 50 ordinary shops of small size. Shops in towns run by men, run by women. 17 in villages, total 18. 3 total 20 1 2 30 35 15 50. Can it be inferred that shops run by women are relatively more in villages than in towns? Use Chi2 test. Solution. Take the hypothesis that there is no difference so far as shops run by men and women in towns and villages. With this hypothesis, the expectation of shops run by men in towns would be expectation of where A equals shops run by men, B equals shops in towns, A equals 35, B equals 20 and N equals 50. Thus, expectation of equals AB 35 20 times 50 equals 14 AB. Hence, table of expected frequencies would be equals ABN times 248. Research methodology. Shops in towns, shops in villages, total run by men 14 AB 21 AB 35 run by women 6 AB 9 AB 15 total 20 30 50. Calculation of Chi2 value. Table 10.9. Groups observed expected OA I2 I frequency OA I AB 171439 14 equals 0.64 AB 1821 minus 3 and 9 21 equals 0.43 AB 36 minus 3 and 9 6 equals 1.50 AB 12939 equals 1.00. Therefore Chi2 2 equals minus OEIJIJIJDI equals 3.57. as one cell frequency is only 3 in the given 2 times 2 table. We also work out Chi2 value applying Yates correction, and this is as under. Chi2 2 2 2 2 17 14 05 14 18 21 05 21 3 6 05 6 12 9 05 9 corrected equals minus minus plus minus minus plus minus minus plus minus minus equals plus 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 25 14 25 21 25 6 25 9 2 2 2 2 BG equals 0.446 plus 0.298 plus 1.040 plus 0.694 equals 2.478. Q degrees of freedom equals C1 R1 equals 2 to 1 2 to 1 equals 1. Table value of Chi2 for 1 degree of freedom at 5% level of significance is 3.841. The calculated value of Chi2 by both methods, i.e., before correction and after Yates correction, is less than its table value. Hence the hypothesis stands. We can conclude that there is no difference between shops run by men and women in villages and towns. Additive property. An important property of Chi2 is its additive nature. This means that several values of Chi2 can be added together, and if the degrees of freedom are also added, this number gives the degrees of freedom of the total value of Chi2. Thus, if a number of Chi2 values have been obtained, chi-square test 249 from a number of samples of similar data, then because of the additive nature of Chi2 we can combine the various values of Chi2 by just simply adding them. Such addition of various values of Chi2 gives one value of Chi2, which helps in forming a better idea about the significance of the problem under consideration. The following example illustrates the additive property of Chi2. Illustration 10. The following values of Chi2 from different investigations carried to examine the effectiveness of a recently invented medicine for checking malaria are obtained. Investigation 1 2 3 4 Chi2 2.5 D. F. 1 3.24.1 3.754. 51111. What conclusion would you draw about the effectiveness of the new medicine on the basis of the 5 investigations taken together? Solution. By adding all the values of Chi2, we obtain a value equal to 18.0. Also by adding the various D, F, as given in the question, we obtain the value 5. We can now state that the value of Chi2 for 5 degrees of freedom when all the 5 investigations are taken together is 18.0. Let us take the hypothesis that the new medicine is not effective. The table value of Chi2 for 5 degrees of freedom at 5% level of significance is 11.070. But our calculated value is higher than this table value, which means that the difference is significant and is not due to chance. As such, the hypothesis is rejected and it can be concluded that the new medicine is effective in checking malaria. Conversion of chi-square into phi coefficient phi. Since Chi2 does not by itself provide an estimate of the magnitude of association between two attributes, any obtained Chi2 value may be converted into phi coefficient, symbolized as phi, for the purpose. In other words, chi-square tells us about the significance of a relation between variables. It provides no answer regarding the magnitude of the relation. This can be achieved by computing the phi coefficient, which is a non-parametric measure of coefficient of correlation, as under phi chi equals 2n. 250 Research methodology conversion of chi-square into coefficient of contingency. C chi-square value may also be converted into coefficient of contingency, especially in case of a contingency table of higher order than 2 times 2 table to study the magnitude of the relation or the degree of association between two attributes, as shown below, equals plus chi2 cn chi2. While finding out the value of C, we proceed on the assumption of null hypothesis that the two attributes are independent and exhibit no association. Coefficient of contingency is also known as coefficient of mean square contingency. This measure also comes under the category of nonparametric measure of relationship. Important characteristics of chi2 test. This test, as a nonparametric test, is based on frequencies and not on the parameters like mean and standard deviation. The test is used for testing the hypothesis and is not useful for estimation. This test possesses the additive property as has already been explained. This test can also be applied to a complex contingency table with several classes and as such is a very useful test in research work. This test is an important non-parametric test as no rigid assumptions are necessary in regard to the type of population, no need of parameter values and relatively less mathematical details are involved. Caution in using chi2 test. The chi-square test is no doubt a most frequently used test, but its correct application is equally an uphill task. It should be borne in mind that the test is to be applied only when the individual observations of sample are independent, which means that the occurrence of one individual observation event has no effect upon the occurrence of any other observation event in the sample under consideration. Small theoretical frequencies, if these occur in certain groups, should be dealt with under special care. The other possible reasons concerning the improper application or misuse of this test can be neglect of frequencies of non-occurrence, failure to equalize the sum of observed and the sum of the expected frequencies, wrong determination of the degrees of freedom, wrong computations, and the like. The researcher while applying this test must remain careful about all these things and must thoroughly understand the rationale of this important test before using it and drawing inferences in respect of his hypothesis. Chi-square test.